Hello, in this video, I'll be going a bit more in depth on breadboards. That's something I've shown and mentioned in other videos. They are an essential part of hobby electronics, although strictly not necessary, but they make connections between small components much easier. Now, the question here is, what is a breadboard? It's a funny little term, but it has historical explanation. Originated with the fact that 19th century circuits were often laid out on old wooden breadboards that were used for cutting bread. This worked well as the boards themselves were constructed of dense and sturdy wood. It really didn't matter if they were still suitable for the original purpose or not. Cracks or imperfections or anything, it still made good for a place to lay out your circuit. Interestingly enough, people were still building these on top of wooden boards well into the mid 20th century. They'd often use metal pins or nails to act as node connectors for wires linking the various components. Now, solderless breadboards were introduced sometime around the early 1970s, which made linking small components easier and more acceptable to hobbyists. You could even use it for small prototypes for professional work. Now, there were some older designs in the 1960s that went with this concept. However, the solderless version that we're all familiar with today was patented by Ronald J. Portugal in 1971, and I think it was granted in like 1973. So that's about the earliest time that you could get these breadboards. They have a series of metal contacts which link to each other, eliminating the need to connect wires together. The power rails on the side, assuming the breadboard has it, are linked in columns, while those in the middle are linked by rows. And there's a very important trench in the middle where there's no link so that you can put in double inlaid pin ICs, which was an important part of these kinds of solderless breadboards that came out in 1971, 1973. They can wildly vary in price, and this depends on the quality, the size, and some other features. You can get some pretty fancy large breadboards actually. The cheapest can be as cheap as a couple of them for, I don't know, $10 USD. You might even find ones that are cheaper, but keep in mind that you get what you paid for. So lesser quality, the springiness of contacts might not be as good. Um, but each hole has sort of a springy metal contact um, that is more likely to hold something than to let go, and that's the important part of the breadboard. Now here you'll see a quick picture of how there's a classic breadboard might be linked up. You'll notice that it's on top of a wooden board here. You'll notice the wire is wrapped around each nail, and each nail represents a node so that the parts actually don't have to be soldered together. This could still be a valid method of building circuits, actually, so it'll probably hold up to larger currents than a cheap breadboard. Although you should note that the wires in this example are exposed instead of insulated, and that could be a potential issue as well. Now, you probably noticed the wire wrapping, and you probably won't be surprised to know that there's actually a technique in surprise. It's called wire wrapping, and actually it can be used as a method for building circuits. It was the basically default go-to method before breadboards, but actually became more refined and can still be used for prototyping. There's even professional circuits that have been built with wire wrapping, although it's a little less common nowadays. You can get thinner wires that can be wrapped with a small, like pencil-like shaped tool, and you might even get find a mechanical solution to that. So the idea is to wrap as tightly around each pin as possible. This works well if your circuit can't conform to a solderless breadboard. You can control the routing in that case. And again, tightly wrapped wire can be used for professional projects. And honestly, if it's really snug, it's not going to be unraveling easily. And here's another example of modern wire wrapping. You'll notice how tightly the wires are actually wrapped around the LEDs and the other components. All right, here we have a typical breadboard layout, or at least one that has power rails. As I previously mentioned, the power rails are on either side of the board. While they are called power rails, they could technically be used for any connection within the columns. The power rails will typically be labeled plus and minus, although sometimes you'll see red and black, red and blue, A and B, etc. They're linked together in two columns, although the two columns obviously aren't linked together. The middle has horizontal labels, usually A, B, C, D, and E. Occasionally, the second area, sometimes it'll be labeled F, G, H, I, J, and there are sometimes vertical labels, which are numbers. If you have both, you can identify a specific hole by the cross section of letter and number. Each row is connected, or at least up until the trench in the middle, which gives you 5 holes on each row to make connections. The trench in the middle is a defining feature of most breadboards. It's meant for double inlaid pin connectors such as dip connection integrated circuit chips. You might have smaller breadboards that lack this though. If you want both power rails active, you'll probably possibly need wires bridging them. Although in the case of things like power supply modules, they usually have connections to both power rails. So in that case, bridging the gap won't be necessary. Lastly, keep in mind, while this is a typical layout, it's not the only layout. There's ones with multiple trenches, multiple breadboards linked together, etc. Now, I've mentioned this briefly, but there's a program called Fritzing. It's very useful for laying out breadboards, PCBs, and schematics. It's very frequently used to show breadboard layouts, especially for circuits revolving around Arduinos and Raspberry Pis, but honestly, it could be used for just about anything. Keep in mind, while it technically does handle simulations and code, each simulated part has to have a SPICE model, and honestly, most of the parts don't do that, so it's primarily used as a cosmetic layout tool. I find it somewhat user friendly, good for beginners, but also incredibly useful even for experts. It's also widely available for a lot of platforms. You got Windows, Mac OS, and Linux. You also have support for Windows ARM and Linux ARM as well, so you can use this on a lot of things. The program isn't free, but it's pretty cheap, and the price is somewhere around $9 to $10 USD. And here's Fritzing. I've already set up a breadboard here. You'll notice the holes and the trenches and everything that I showed you. And I've pulled up a model of power module. I think it was the first one I showed in that I have a bunch of. Now keep in mind, there's no SPICE information. This part can't be simulated. And again, that's true for most things. Let's get out a resistor. Let's get out an LED because that's really the only things we need. The resistor also does have some SPICE information, so I guess it could work for a simulation. Let's see. Now we've already got the power rails here for minus, so that maybe at least that's simulated. Come to think of it, so what I can do, let's change this to just 1,000. We've been using 1,000 when we could. Let's see. Yep, 1K right there. Change the bands? I wasn't paying attention. Now keep in mind each of these rows are linked together and each of these columns are linked together. So what we can do is we could do, let's see, what's the rotating thing again? Okay, that's not it. I can never remember what the keys to rotate are. All right, so let's link that and that. So now we've got a resistor, actually, whoops. Okay, now we've got a resistor between positive and this row. So this row is live now. So let's change our, oops, that's not what I meant to do. Flip this, I think. All right. Okay, so I have our anode on this side. So this one now is the ground. You'll notice it's actually highlighted. So let's see, let's do a wire. Wires aren't the greatest to look at, but they should give you an idea. And just to be right, let's do black. So in theory, if we could simulate this, should work. I guess that's lit up. I'm not entirely sure. But yeah, this is how we would use to show a layout in real life, and this is a lot better than some of the other programs because again, you've got a picture that looks just like the power supply module. You got yourself a little red LED resistor. The wire obviously isn't realistic because all this in real life would be 3D. Although I think there's a way to do 3D or make it a little more 3D. I'm not entirely sure. But if you show this to somebody, it should make things pretty clear. Also, a quick reminder that Tinkercad can do a breadboard layout with a focus on either the Arduino Uno Rev 3 or the BBC Micro. The number of components is extremely limited, but again, it could be a good start and perhaps a bit easier to use than fritzing. I've also mentioned Walkwe previously. It's another simulator. It's web-based and it built around simulating development boards. But again, it does have breadboards, so you can do a breadboard layout with it. Okay, just to recap, breadboards were once literal wooden breadboards with copper wires that laid out a circuit, although nowadays we have solderless breadboards, which came out first around 1971 or so. They use little spring contacts and linked holes so that you can mount components. They do vary in size, quality, and cost, but you can get a couple of cheap ones for around $10 USD, maybe even cheaper, but keep in mind that you get what you pay for. Wire wrapping is another good alternative. It goes back to how circuits were originally laid out. It lets you decide what's connected and what not by tightly wrapped wires between each component. It's essentially a growth from the classic circuit prototyping, and even with solderless breadboards, it's still used today. Fritzing is a good program for breadboard layouts, costs about 910 USD, has a large variety of components which are added to literally daily, although most of the components don't have simulation models, so for the most part, it's just really good for cosmetic layouts. Tinkercad and Walkwe also have breadboard layouts. There may be other programs. And until next time, have a good one.